So in this video, I want to very briefly review some of the calculus concepts like derivatives and integrals with respect to trigonometry. This video is designed more of a review of just the basic 6 trigonometric integrals and basic 6 trigonometric derivatives for things like sine, cosine, tangent, cotangent, secant, cosecant, and how they're related. I'm not going to go into all of the extra stuff with some of the more advanced trigonometric integrals or trigonometric derivatives. I'm just going to cover the basics here. So first and foremost, the first one I want to start off with is if I take the derivative of just sine x. Now, hopefully everyone remembers that the derivative of sine x is cosine x. Important thing to remember here is, again, we're trying to match up where sine of x is increasing with where cosine of x is positive. And same idea, vice versa. If we do decreasing sine of x, it should be a negative answer for cosine. And so that's one of the ways that I always try to do to just remember how they match up, is to think about where one's increasing versus decreasing. Now, if I do the same idea with cosine, it gets a little bit trickier because cosine, if I look right at 0, it's decreasing as I head toward x values of pi over 2 or pi, and sine is in fact positive over there. So what I have to do is I have to change the sign, S-I-G-N. I have to make it from positive to negative. So notice this was a positive cosine, and that's a negative sine. Now, again, the question I get a lot, or the probably most frequent mistake I see when people are doing derivatives with trig functions, is that they don't remember to change it from positive to negative or negative to positive. And so the trick to remember there is if you start off with a whether it's cosine, cosecant, or cotangent, that's when you know you need to switch it from positive to negative or negative to positive. Let me keep going. So we're going to take the derivative of tan x next. And the derivative of tangent is secant squared. Continuing the same line of reasoning, if I take the derivative of cotangent, instead of it being secant, we're going to have cosecant squared. And again, we're going to have to change it from positive to negative or negative to positive. Couple more. We've got the derivative of secant x, which is secant x tangent x. And similarly, we've got the derivative of cosecant x, which again, remember, don't forget to switch it from positive to negative or negative to positive, of cosecant x cotangent x. All right. So these are all of the special derivatives that you're supposed to know regarding the trig functions. I'm going to also talk about integration. Now, the thing to remember about integration is it's just the reverse. It's the inverse process of derivatives. So, for instance, if I try to take the integral of cosine x dx, it's saying, okay, I know cosine is the derivative. The question is, what was the original function? Well, in that case, if I pay attention, the answer is sine x. And since this is an indefinite integral, I'm going to put plus c at the end. So I'm just going to kind of follow the same logic up here. Up here, we're going to talk about sine of x next. So if I try to integrate sine of x dx, the opposite or the inverse kind of process of this should lead me to cosine, but notice I've got this one little hiccup here, which is the change in sign. So originally, cosine over here is positive, and that sine is negative. Well, down here when I'm talking about this, I'm saying the integral of positive sine x. Well, I'm just going to kind of follow the same reasoning. This is just going to change sign. So instead of it being negative sine x to positive cosine x, this is going to be a positive sine x to a negative cosine x. And so again, the kind of trick to remembering this is if you end with a if your answer has a cosine or a cosecant or a cotangent, that's when you need to switch from positive to negative or negative to positive. Continuing, we're going to do the integral of secant squared x dx should lead us to tangent x plus c. Again, I'm just following the same logic. If that's my derivative, what's my original function? Three more. So the integral of cosecant squared x dx should lead us to negative cotangent x plus c. Again, notice my answer has a co in it, so we're switching from positive to negative or negative to positive. And two more. So we're going to integrate secant x tan x, and we should end up with, our original function was secant x plus c. And if I integrate cosecant x times cotangent x dx, we should end up with negative cosecant x plus c. Again, we ended with a cosecant, so we're having to change that sign from positive to negative. Hopefully this does help you review all of your trigonometric functions, as these are going to be very important in subsequent lessons.